Hello everyone. In this video we're going to be solving a homogeneous equation with constant coefficients, but in this case based on the form of the equation we are going to get complex conjugate roots. So looking at our equation, 9y double prime plus 4y equals 0, with the initial condition that y at 0 is equal to -3 and y prime of 0 is equal to 1. Our characteristic equation is going to be 9r squared plus 4 equals 0, which we can solve fairly easily by subtracting 4 and then dividing by 9 on both sides. And this gives us that r is going to be equal to plus or minus the square root of -4/9, which of course is going to be plus or minus 2/3 I. So we're going to have imaginary roots for this. Notably, these roots don't have real parts. Normally we would imagine that we have roots of the form lambda plus mu I, but in this case lambda is going to be equal to 0. So when we write down our form for the general solution, we normally think of it as e to the lambda t cosine mu t plus c2 e to the lambda t sine mu t. But in this instance where lambda is equal to 0, we're going to get e to the 0, and e to the 0 is equal to 1. So we're just going to have cosine of mu t plus sine of mu t as a linear combination. And with our specific value, this tells us that we have a c1 of cosine of 2/3 t plus c2 of sine of, or times sine of 2/3 t. At this point, we can apply our initial conditions. And that is most easily done if we go ahead and differentiate our general solution first. So we're going to get -2/3 times c1 times sine of 2/3 t plus 2/3 c2 cosine of 2/3 t. If we evaluate at t equals 0, for y of 0, we're going to have -3, and that is going to be equal to c1 times cosine of 0, because 2/3 times 0 is 0, plus c2 of sine 0. And this tells us that c1 is going to be have to be equal to -3. And then if we plug 0 into our equation for the derivative, then we're going to see that that is equal to 1, which is equal to 2/3 times c2 cosine 0. Of course, the sine term is going to have sine of 0, so that's going to be equal to 0. And this tells us that it must be the case that c2 is equal to 3/2. So this gives us our solution to the initial value problem. where we have y of t is equal to -3 cosine 2/3 t plus 3/2 sine of 2/3 t. All right, thanks for watching.